We are going to learn rectified linear unit. It is fx equal to ReLU beta plus omega x. So beta is the vector constant, omega is the matrix of constants, x is the vector variable, and ReLU is rectified linear unit here. So this one also can be represented as max 0 b plus omega x. So the function takes the maximum value between 0 and beta plus omega x. If beta plus omega x is positive or 0, it will return beta plus omega x. But if beta plus omega x is negative, it will return 0. So the key point is this is actually a non-linear function used in artificial neural networks. So in simple term, the function is like a switch. So as I said before, if it represent the b plus omega x represent 0 or positive result, and if it is like that, it let it go without changing anything. But if it is a negative result, then it blocks it and gives you a 0 instead. So the few reasons why you use this, because of it's more efficient than the other mathematical operation like logarithms, and sparsity. In context of neural network, sparsity actually refers to a property where a large proportion of the value in the dataset is 0 R0, and it is actually you might describe this as a emptiness. As a result, like when it happens because of this algorithm, because of this function, it effectively deactivates certain neurons. So here you can see that there are lots of zeros here. So obviously, if there are lots of zeros, it means that it will make it easier to do anything. So there are some other benefits like gradient descent. So this concept actually I will discuss later on if needed. So basically these are the benefit of using that function, and even though it looks like a simple function, but it plays a critical role in the deep learning model.